Yeah, the first thing we gonna create is the radius of our duct or pipe. Set it to 40 millimeters, and we create another one for the depth. That's 3 millimeters. So these are the most important parameters. Then we create a circle, enter the radius. Yep, that's our contour. From this we want to create our like a solid slice, and for this purpose we take this contour, create like a face from a planar curve here, and then we extrude it in the into the Z direction using the depth. So here it's still open, but we can close this extrusion, and then we have like a closed solid here. It's gonna be our grid slice. Okay, we put everything into a scope. Call that 0, 0 slice. So that's our starting point now. Okay, so the next thing that we are going to create is actually a single element for our pattern, of the grid pattern, and the thickness of this grid is quite important, so we create a design variable for that, and another one for the width as well, like the width of this single element of the grid. Yeah, then we start to create this contour of the single element, creating a point and entering the width for the x coordinate, but also for the y coordinate, and so we slightly shift it a bit backwards, so that we can apply Boolean operations later on. So this is the second point, and the third point, always using copy and paste. And that's the last one. So then we can select all the points and create a B-spline curve from this. Linear degree, and we add the last point to close the contour. Yeah, so that's the contour of our single element of the grid. And we now want to create a solid body from that, again to use it later on for a Boolean operation. That's our face, and again we add a new operation where we extrude. Using the depth. So this is our body, again closed. So in this piece now we will use for our pattern. So yeah, so far it maybe has been a bit boring, but now comes the interesting part. We create the pattern, and for this we need some parameters that I set up here. So we need the number of, let's so to say, like holes, and also we need the single width as well. This the width of a single element when we apply the pattern feature in a second. So these are important parameters derived from the thickness and the width. And then I have a feature where I can simply enter the the base geometry, and it will create a pattern structure. And we use our parameters here. So this is the pattern. We want to have a symmetric pattern based on the origin, so we can use that little toggle here. Okay, so in this next step we will put together our solid grid slice with the pattern, and for this we create another B-rep with the grid slice. That's what you're seeing here, and then we take our pattern and choose difference here for this operation and apply it. Switch off the element. Okay, so this is our very nice grid slice. And of course we can now change the parameters such as the thickness or the width, and everything gets changed. So this works pretty well. And again we put everything into a scope to have a nice project structure. So this slice cannot be used for CFD calculations so far. So what we are going to do now is we also create the pipe, like the entire duct, and merge it with this grid slice. So first I create another image curve and translate it into the negative Z direction. And based on this, it's again quite simple to create that pipe. We use this contour curve here, this 2D curve, and extrude into the Z direction. So we simply take 500 millimeters, but you can, of course, have some parameters for this as well. We close the extrusion, and that's our pipe. So, but this is also again an interesting step. We take our rectangular grid, that's the circular grid, and apply a difference to this pipe. So and then we have a very nice combined device here. So we can take a look into it with the clipping planes. So you can see it's a nice solid, a solid that can be used for, readily used for meshing. And rename it again, and put everything into a scope. Actually, that's our CFD geometry here that we are going to use for the meshing and the CFD. That's pretty much it.